Hello, everyone. Welcome to the third seminar organized by the SIG on Spoken Language Translation. My name is Marco Turchi, and I am the secretary of the SIG. Here we have also the chair, Professor Satoshi Nakamura from NICE Institute. Hi, Satoshi. And yeah, the SIG is a special group on spoken language translation. And in our interest, we have all the topics related to translation and simultaneous translation, interpreting, dubbing. Thanks, Prashant, to be here today talking about this activity, speech to text, and so on and so forth. ISCA has a special interest in spoken language translation, has the idea of grouping people working on this topic and exchanging idea, recent paper, and improve and enhance the research on spoken language translation. Among the main activity and purpose of the SIG, there is the sponsor organization of the International Conference of Spoken Language Translation. So that will be at the end of this month in Dublin, and make available resources and code to the community. So one of these new activities is also the organization of this series of seminars, where we hope that we can make available to the community interesting and recent advancement in our topic. And today, the speaker, we are very happy to have Prashant Mathur, who is a research scientist, senior research scientist at Amazon, and former FBK PhD student. That's important. Yes. So thanks a lot for being here, and thanks a lot, everyone. And so I leave the floor to Liz, who is going to moderate the session, and then thanks, Prashant, for your time.
Yeah, excellent. Well, I think with that introduction, we'll pass it directly over to Prashant. But if anyone has questions throughout the talk, please feel free to put them in the chat or directly unmute when there's a pause, and we can answer throughout and hopefully have a nice discussion at the end too. So yeah, with that, I'll pass it over to you.
Thank you. I'll start sharing. Okay, can you guys see my screen?
Yep, perfect.
Cool. So hi, everyone. I'm Prashant. I'll be talking about isochrony problem in automatic dubbing. So just a tad bit about myself. I'm a senior applied scientist at Amazon working on typically science problems related to dubbing. So it involves machine translation, and we'll see a bit about prosodic alignment. In this talk, I will cover mostly the work done by Yogesh, who is in this call now, Surafil should soon join, and Marcello, who also happens to be the advisor of me and Surafil. And yeah, we are all from FPK. Yeah, so continuing on. So when I talk about, or when we talk about dubbing, what's the first picture that comes to the mind? Like person standing in the dubbing studio and reading dialogues, and these dialogues are kind of in the end or replaced with the original audio in the audiovisual content that we have. I mean, of course, this is correct, but it's not just this process. There are around more than 100 steps in this dubbing localization process. So among them is like transcription, translation, adaptation, voice talent. You cast the voice talent. You have dubbing sessions with them, not just one, but multiple dubbing sessions with them. Then you run like fine synchronizations with the audio and the video. You do some kind of audio mixing. There are some noises in the background, so you mix them, and then you generate the final content. So it looks simple. There are a lot of processes behind it. It's very well established in some countries like Italy, France, Germany, Spain. They all have their own dubbing standards. So each script in these different languages, they are very different. So when you look at them in Spain, you would find scripts that are based on number of ticks, while in Italy, you would find scripts that are based on dialogue lines. Yeah, so not to confuse dubbing with different other terminologies like voiceover or lecturing. Voiceover is basically when you overlay the translated speech over the original speech on top of it, and you kind of fade out the original audio and then fade in the translated speech. And we can see the demo in the appendix if time permits. Lecturing is basically very specific to Poland. So the idea is that a single actor basically reads all the dialogue lines, whether it's male, female, or any other gender, and they read it in a very monotonic voice. And this is preferred by the Polish community over any dubbing or voiceovers. It's different than voiceover, it's different than dubbing. Dubbing is basically, it's different from lecturing and voiceover in the sense like translated speech is now replaced with the original speech. Yeah, so what dubbing is basically, it's essentially seamless translation of the video from source language to the target language. And right now, all the dubbing work, automatic dubbing work at least, it's still a pipeline-based process. So when I say pipeline-based process, in the sense there is a source separator component which works on the audiovisual content. We get the audio from that, and then we run the speech recognition system, then we run the machine translation, TTS, and then generate the end audio. In between that, there are other multiple steps, so we can talk about that in a bit. But overall, it's, yeah, again, right now it's mostly a pipeline-based process. So we can think of dubbing as a speech-to-speech translation, but it's a lot more than that, because dubbing is mostly done on creative media content, which implies that there is a lot of creativity in the text itself, like idioms. When, like you can say, you are kicking a dog when it's down, come on. So it's difficult to translate these kind of phrases in the target locale if there is no one-to-one translation of the idiom, where you can even have abbreviations like 911 in English could be translated to ambulancia in Spanish. So there is no direct translation as such. At the same time, there is another component of in dubbing, which is lip sync matching. So essentially the translated speech should match the actor's lip movements when it's speaking. So that's one thing. This leads to a problem of synchronization, which I'll talk about in this talk. Synchronization is one of the major problems in dubbing. And then I'll talk a bit more about a related problem of isometry in translation, which is also, there is some sort of causal behavior between the two. So we'll see a bit more in context there. Let me show you like a video first, and then we can move to what the problems are when we actually end up dubbing the content.
He is a poet, a playwright, a man whose whole life had been balanced on the single hope of his country's unity and freedom.
So we saw the lady basically speaking a whole sentence, but what happens is she's not really pausing at a very syntactically aligned kind of manner. She can pause at any point that she wants. She can pause to take a sip of water, to think what are the next few words that she has to speak, or stress on certain phrases. So what happens is when she takes the break, she says, he's a poet, then pause, playwright, pause, and then the rest of the sentence. We call these this phrase pause structure, and each phrase is basically, we denote this as prosodic phrases. Ideally, when we get the translation from the empty system, we want to kind of align this translation with the same structure that is in the source. So we cannot really align "he's a poet, a playwright" with a single phrase, because they are two separate phrases with pause in between. So we need to align those. So this is basically the problem of isochrony. So isochrony is basically used in context when the speaker is on screen. So in this particular case, we have un poeta, un comediografo, and so ideally "he's a poet" should be aligned with un poeta, and a playwright should be aligned with un comediografo, and the rest of the sentence, so on and so forth. Yeah, so this synchronization is kind of needed in order to achieve isochrony. Again, with the lip movements, we need to adapt to that. But these constraints, they are not really applicable when the character is off screen. So when the character is off screen, we don't really have to run these alignments. We can just continuously put all of the phrases together. Because the character is off screen, so we wouldn't notice these things. These things are noticeable when the character is on screen, and when the lip movements are actually visible, they are within the plus minus 30 degree kind of. That's the rule of thumb. So where do we put these pauses in the target side? This is basically what we are going to talk about. It's called prosodic alignment. Any questions so far? Okay, so yeah, in prosodic alignment is basically a task of aligning these prosodic phrases from source language to target language, where we have the inputs: source speech, source text, target translation, and the output is kind of a phrase pause structure. So ideally, output would look like this, where we have un poeta with 2 dots, or we can put anything we want. That this basically denotes that there is a pause. So what happens when we incorrectly align or correctly align these phrases? So if we incorrectly align un poeta and the second phrase is a playwright, and if we incorrectly put a pause after "on," this would basically mean that we have to really slow down the speech on to kind of maintain the same time codes between T1 to T2. And we would have to speed up the speech on the rest of the sentence because it doesn't fit in the same time threshold. Whereas if you correctly align, you wouldn't have this kind of an issue. Ideally, especially in our case, we first force align the source speech with the source text to get understanding of where these T pauses are, T0, T1, or Ti. And then we look at the target translation, and then we look out, okay, where should we put the pauses in the target translation? So yeah, let's look at what happens when it actually went wrong.
È un poeta. Un commediografo, un uomo la cui intera vita poggiava su un'unica speranza, unità e libertà per il suo paese.
So you would see, like, even when the lips are not moving, there's audio. When the lips are actually moving, there is no audio. So this kind of misalignment is very noticeable in dubbing. But what happens when the dubbing is actually correct?
È un poeta. Un commediografo. Un uomo la cui intera vita poggiava su un'unica speranza, unità e libertà per il suo paese.
This is much better, right? This is correctly aligned. So this really affects the quality or the user experience, the end user experience that we are talking about So this is basically the problem of prosodic alignment. And it has been explored before, but not much in dubbing, because dubbing itself is a new field right now. It's being explored. Nothing is clear, nothing is right now standard. Everybody's still under the exploration phase. So one of the first works was by Alpoctem and another person, where they kind of looked at, okay, let's try to align based on the content. So at that time they used a sec-to-sec model with attention, where they just aligned the pauses. First they got the word alignments using the attention, and then they found they basically looked at what are the prosodic phrases in the source side, and then they tried to align it with the word alignment and try to make it monotonic as possible. So this is how they did it before, but it turns out that, you know, content-based matching is not enough. We need to think a bit more in terms of how the dubbing quality will be at the end. So this is where Marcello's and Yogesh's work come into picture. So where they basically say that all the content is important, it is also important to maintain fluency of the speech. And previous work did not take into account like speaking rate. Speaking rate is basically so let's say we have a phrase, he's a poet. So we have the original audio for that, and we'll try to run it with the TTS generated speech. Again, the same thing. And we'll see, we have the original speech, he's a poet, and then we'll run the translation, you in poeta, with TTS speech. And then we'll see what is the duration of the TTS speech versus the original speech. And this is basically the speaking rate that we get. And if the speaking rate differs too much, or it's basically saying that there is a problem in fluency. So it's likely that your speech is either too fast or too slow. So the proposal they had was, okay, we'll try out dynamic programming, dynamic programming search, which is based off Markovian model. So essentially, it's like a log linear model over multiple features based on speaking rate and content match. Yeah, so these features are basically like fluency-based features. One is duration match using character count. So they basically count the number of characters in the source and in the target side and see what is the match between them, or a ratio. Speaking rate variation. So how speaking rates of the contiguous phrases differs from each other. If the speaking rate of the first prosodic phrase in the target side is like 0.8 and the second prosodic phrase is 1.5, there's a lot of difference. So you would have a very slow speech and then very fast speech and then very slow speech. So that's another issue. You have there is Isochrone Score, which is basically looking at time boundary relaxations. So the idea is basically we have the pauses, and we kind of see if we can use the deltas, like a small amount of pause time, to actually fit the length of the target phrase. And they basically do it like try to extend the start and end times of that target phrase. And this basically helps. And this is like a relaxation constraint that they have, and it kind of helps in improving the quality of the dub content. Again, then there are multiple other ones like content-based features. They use so yeah. The previous paper used parts of speech LM, where the idea was that we don't want to put the pause between an article and a noun. So that's where it kind of helps, this particular feature. And later Yogesh basically in his work basically proposed, let's add the cross-lingual semantic match. So they use laser embeddings and then ran a cosine similarity over the prosodic aligned phrases, so between the source and the target phrase, and that kind of helped. So this is basically like, I kind of split this into fluency-based features and content-based features. So we have to look at both of the things, not just one. Yeah, in terms of experiments, they looked at TED Talks from the must-see corpus. The source was segmented, and the empty they had the empty output from another system. They kind of post-edited it with the guideline that's said, okay, try to match the length of the source with the target. And then they added these pauses in the target side too. So this is how they created this data set, which is very useful for prosodic alignment evaluation. They evaluated on 4 different language pairs. This is kind of our standard now, at least in our team. We are working on these 4 languages. Yeah, and for evaluation, we use accuracy of segmentation. So how accurate we are aligning the pauses. If the pause is actually not in the correct place, even if one pause is not in the correct place, then we kind of ignore that sentence and move on. And then there is fluency, which is basically saying what's the percentage of sentences having a speaking rate for all the segments within the 60 to 140% range, so plus minus 40%. Smoothness is basically a measure of stability in the TTS speaking rate across the contiguous target segments. And for human evaluation, so these are basically automatic evaluation metrics. They basically use speaking rate measures to run the, I mean, you can look at the paper, it's more there in detail. Yeah, and then there is also human evaluation. So the idea is basically we want to evaluate the dubs in terms of their naturalness. So how natural the dubs look. This was one of the Mushra evaluation metric that was proposed sometime back in 2014. They proposed on a scale of 0 to 100. We kind of reduced it because of inter-annotator agreement, and we reduced it on a scale of 0 to 10. So basically, what the annotators see is the reference dub that we give them. This is how the reference dub looks like, and these are our hypothesis dubs. And can you evaluate these dubs on their naturalness? So when they compared the previous paper of Marcello and the latest work, which the difference is basically that there is cross-lingual semantic match with laser embedding. Then there is a updated feature on the scaled speaking rate match. And then there is another feature updated. So the idea was basically how we can improve, or the problem was how we can actually improve the quality of prosodic alignment, because that was one of the bottlenecks. How we can improve the accuracy of prosodic alignment. So we actually ended up improving from 40% to 76% on an average across 4 language pairs. And that was a big jump at that time. With added relaxation, like with the time boundaries, deltas on the left and right, smoothness and fluency actually improved a lot. So yeah, I mean, you can see, like, I'll show a couple of dubs, how things changed from 2020 to 2021. This is the original video.
This is not a question between privacy against security. This is not a question.
Sorry. This is, so that was the original video, and you'll see the 2020 video that we have.
Non è una questione tra privacy e sicurezza.
So you would see, maybe you would realize that the first phrase was very slow and then kind of picked up pretty fast. So this was one of the things that people pointed out when we asked them to, okay, how did you like the dubs? What did you have? Do you have any comments that can help us improve? And this is what they kind of said, okay, there is a fluency factor there. Yeah, so this is the improved model.
Non è una questione tra privacy e sicurezza.
So at least the fluency improved, and that kind of helped with raise the quality of dubs overall for us. Yeah, so the takeaway is basically that higher accuracy on pause alignments is really necessary. And speaking rate features and time boundary relaxations, they actually improve a lot on the smoothness and fluency. And you can find a lot more in the paper by Marcello and Yogesh. I added it as a reference. So yeah, this is basically the first half, and now I'll move on to the MT part. Is there any question, or should I just continue? Okay. Continuing to MT. So from isochrony to isometry. So yeah, this is something that we have been working on for a while. We don't have concrete answers for anyone yet. We are still exploring lots of papers on this, and that is helping us improve the quality of dubs, helping us improve machine translation even for other use cases. So let's first look at what is isometric MT. So how we define it as it is basically the length of translation should be within the range of plus minus 10% with the length of source. So if you look at this particular example, that's about the size of my hand on each of the plates. And the standard MT, which doesn't have any control over the length of the translation, they would generate any length, right? So in this particular case, they are generating translation which is not within that plus minus 20% range. And this kind of cause other problems downstream for us, which we'll look at it in a moment. But when you look at it from when we actually control for the length of the translations, you would see the translation quality is still at par. We might take a hit, but we do want to control for the length. And this is the case basically of isometric MT. Yeah, why is it important for dubbing? So translations, they need to fit into the same duration as the source. And we kind of took into assumption that duration is directly proportional to the number of characters that there are. It could be better in the sense like the duration is directly proportional to the number of syllables. But right now we are just looking at the number of characters. So what happens is if you have a too long of a translation, you end up generating very fast speech, right? Or if you have a too short translation, you would end up generating very slow speech. So this is like a huge problem. Even within the phrases, the prosodic phrases, we have to control for the length, not just the whole sentence, but even within the phrase. So without isometry is also very difficult to achieve isochrony in dubbing. This is where the causal factor lies. And if the translation is like within the plus minus 10%, we can still, you know, extend or contract the vowels at phoneme level, or even allow for the relaxations that we talked about in prosodic alignment. And that could help, but it has to be within the range. If it goes beyond the range, we have kind of seen that dubbing quality is dubbing quality with the standard TTS model that we have, it takes a hit. So where else this isometry comes into picture? What are the other use cases? Like not just dubbing, but it's also useful for subtitle translation, where subtitles are actually shown on a block of screen, and it has a predefined length, right? Each block has a predefined length. So we essentially need to rephrase the translation to fit within that particular length. Document layout translation, where if you are translating a text within the table that has a predefined width, then we also need length control there. Simultaneous empty, it might need length control because essentially we shouldn't really generate long translations for a very short phrase and a very short translation for a very long phrase. So these kind of things, they are a good use case for isometric empty. Again, another problem we have is data is essentially not reflective of the problem. It's mainly because the translations, they were done without dubbing use case in mind. And even like, I mean, the translators in TED, they don't really have any constraints on DTS or length, right? So essentially you could generate any length translation. And this is what we also see in the must-see data. So there's a lot more bias towards longer translations than the length compliant translations, what we call plus minus 10%, and the short translations. Yeah, so the idea is like we could balance this out. We could essentially try to rephrase the translation and make it short, and so this is what we do and what previous works also have done. So there are a lot of components here, but essentially the ideas are around certain things, like you can either add a verbosity token saying that I want to generate a short translation, normal length translation, or a long translation, and the model can generate it if it's trained on these translations. So what we can do is at the training time, we can look into, sorry, what happened? Yeah, at the training time, we can look into, yeah, let's go here maybe. At the training time, we can look into what is the translation and what's the length of that particular translation, and see what verbosity level it maps with. So it maps with either short or norm or long. So we can add that particular token, and this is how we can train the model. So this is basically the work of verbosity token. Similarly, we could essentially add verbosity embeddings here within the model, or you can have a length penalty that was there in the Google's paper. What works best right now are it's basically a combination of the verbosity token and the hypothesis rescoring, where, see, I'm taking a break and it's not a syntactic pause. Yeah. So here, yeah, with the hypothesis rescoring, we first generate the n-best list, and then we rescore the hypothesis, like the n-best list, based on the translation quality. But at the same time, we also look at the synchrony score. So synchrony score could be just based on what's the length of the translation what's the ratio of the length of the translation with the length of the source. And we could essentially work off that. Sorry, I can't see chat, but I see a notification. Yeah. Okay. Yeah.
That was
I
just
think
a
it's
joke, Prashant. You can keep going. Yeah. You said it was a synthetic pause. I was saying that hopefully you're not AI, Prashant. Just wanted to have a quick pause and break, and thank you for the great presentation. Move forward, please.
Yeah, sure.
Prashant, may I ask you something?
Yeah, sure.
When you talk about length, do you always consider characters, or you have some other subunits that you can use more related to, I don't know, speech or something like that?
Yeah, so this work of Sabu in 2020, they looked at the syllables instead of looking at the characters. And I think this is where we should be heading to, looking at the syllables rather than just looking at the characters, because it's easier to contract or expand the vowels than the consonants. So we need to look into, whether we can, when we are translating, how are we ending the word even? So if you are ending with the vowel or if you are ending with the consonant, and that could even change the way we pick the next word for translation. This is something, I mean, we can explore, of course. Yeah. Yeah, so these, there are not much happening in this area, to be honest. I think, yeah, lately with a couple of more papers from, I think, AppTech, who's working on this subtitling, and there are a couple more, and I think also Huawei participated in one of the shared tasks that we organized. So I'll talk about that a bit more. But yeah, I think this is how the state is right now. Not much word, but it's slowly picking up. Yeah. Yeah. So what happens when we actually use these tokens? When the model actually learns to paraphrase, they drop sometimes unnecessary words like function words sometimes, or they use simple verb tenses. And I mean, this is another way of rephrasing, I would say, right now. Yeah, so like I was talking about rescoring or synchrony, the idea was you generate the n-best list, and then you can linearly interpolate with the translation quality and the synchrony score. And this is what we are using right now, but it kind of adds a re-ranker component on top of the already existing MT. So it's basically, we are already working on the pipeline-based approach. So why keep adding models and models on? So we need to kind of reduce the models, not increase the models. And this is where this self-learning work kind of comes into picture. So the idea was, can we actually reach the performance of this verbosity control with the re-ranker just with any other method, because this is just another component that we have added in our pipeline. Ideally, we would want to remove that. It's just difficult to maintain these things. So yeah, I mean, the idea of self-learning work, and this is Surafil's work to call out. Yeah, so the idea here is like, let's pre-train a verbosity control model with verbosity tokens. And then at runtime or at training time itself, we'll generate synthetic data using the parallel bytext. And ideally, we would want to train on the model's prediction, and we could tell the model to generate normal length token or normal length translation in the training itself, and train the model on its own prediction, so on and so forth, to make it more biased on these normal or shorter translations. How we do this? So we basically take, multilingual encoder is basically like a bilingual or bidirectional model here. So idea is basically that we first add language tags to the encoder side. So we have added source and target tokens here, source and target language tokens here. On the decoder side, we also add the source target language tokens, but we also add the verbosity control tokens. So essentially, it's a multilingual and a multi-verbose model. So yeah, the idea is that we first pre-train the verbosity control model with just this component, and then at the training time, what we do is we basically ask the model to generate on a sample of data. We first generate the translations with the normal length token in the target language, and this pseudo target and pseudo source that we get on this sample of data, we classify that, or we kind of filter it again. So we know what is the length of the source, and we know what is the length of the pseudo target, and we know what is the length of the original target, and we know what is the length of the pseudo source. So we generate basically or filter out we filter out this larger sample, and we create a smaller sample that is actually length compliant. Even if we apply normal verbosity token here, it's not guaranteed that the model will generate a normal length or length compliant translation. So we need to still filter out the length compliant translations from this generated data. Once we have that, what we do is we plug that in again and combine it with the original data. We have the pseudo data too, and then we train on that mix. And this is how, we can do this on and off between step 2 and step 3 for n number of rounds until the model converges. In our setting, we are running it for like 5 epochs, and we are basically taking the checkpoint which has the lowest loss. Yeah. In our experimental setup, we again evaluate on EN to FIGS. Our training data is our larger internal data that we train the model on. It's much larger than what we have at the moment in the open source setting. In the open source setting, we have the must-see data that we use for fine-tuning. So we have around 250K samples per language pair. What we use as metrics is, for the automatic metrics, at least, we have the length compliance, which is how many sentences are within this plus minus 10% range. And then we have the blue, as the translation quality. At that time, we used a single score. So we reported the multiplication of the length compliant with the blue score, and that kind of, because ideally we want to know how does the model stand in terms of translation quality and length compliance. We don't just want to look at each metric separately. So this is how these were the automatic metrics at that time. And in terms of human evaluations, we evaluated using audio. So we basically generated the audio using TTS, and then we provided the translators the reference along with the hypothesis, and then we ask them to rate the translations as acceptable or fixable or wrong. And then we kind of assume that the acceptable translations, they won't require any post editing, while the fixable ones, they would require some minimal post editing. So we kind of weighed it accordingly. So overall, the human evaluation score, we rated it as length compliant, or how many sentences were length compliant and acceptable, how many sentences were length compliant and fixable. And we weighted the fixable ones with 0.5. This was the final score for human evaluation. This is how the setup looks like for the audio evaluation, where we have the reference sample. You can just click on this and user will hear the audio from the reference. It's needed because they don't know what context the translations are in. And then you have 3 different hypotheses. Here you can rate it on a scale of 0, 1, and 2 accordingly. And we use RVD for our subjective evaluation, which uses Turkers in the background. So since we use Turkers, we used around, okay, I'll talk about that more. So what we compared were 4 different models. One was the verbosity token model, and then on top of that, we used the reranker. We also compared the self-learning model and self-learning plus reranker to see where we are right now. So this basically tells us whether self-learning itself is enough in comparison to VTalk plus rerank. But this was more of an oracle for us because there's another component here. While the self-learning MT didn't really have understanding of, it was not really molded to the synchrony score. So yeah, the results we have here are basically showing, isometric MT is basically like the self-learning MT one. Isometric MT plus rank is the re-ranker one. Yeah, here you would see the LCB, which is the blue times length compliance score. Overall, I mean, self-learning kind of works almost at par for English, French, German, Spanish, but it kind of falters on the English, Italian. We are still working on the Italian part now to understand like what really happened here. And then if we actually combine the self-learning work with the re-ranker, then of course we get much better improvements over all language pairs that we have. So on an average, we kind of surpass the previous VTalk plus re-rank work. In terms of human evaluation, again, VTalk plus re-rank, of course, it's much better than the just simple VTalk, which is verbosity control work. When we compared VTalk with isometric MT work, this time we had a bit different results. Human evaluations, not always in line. Yeah, so we got good improvements over all language pairs in comparison to the VTalk plus VTalk work. We also ran evaluations, I think, for VTalk plus re-rank. I don't have those here, but you can see in the paper, I think. Yeah, so this basically was our latest work on how to control for length of translations. Really helps, really works very well for us. And I hope it's kind of picked up in the community, not just, I mean, you can essentially use this self-learning, not just for verbosity control, but for anything like formality, or if any other control you need for style. It's not just limited to verbosity control. That's what I meant. You can see more in the paper. We also ran dubbing evaluations on the empty outputs. And there we also saw some interesting phenomena happening. Lastly, I would want to plug in the isometric empty shared task if there's time. Okay. So this is the first shared task that we are organizing with Surafil, Yogesh, and Marcello. The challenge is, like we talked about, generating high quality translations which are similar in length to the source. So it's not just about the quality, but also the length. There were multiple, two settings. One is the constrained one, the other unconstrained. And under the constrained setting, we only allow must-see version 1.2. And unconstrained one, we allowed any use of pre-trained models and use of WMT data. For the test sets, we had must-see, test common, test set. For the blind set that we developed in-house, we had around 200 phrases, sentences, which are basically 91 dialogues. And they are based on open source YouTube videos data with Creative Commons license. You can see the data on the website, on GitHub, basically. And we evaluated on 3 different language pairs: French, English, French, German, Spanish. We didn't have, there were some issues with the Italian, that's why we dropped it. For empty evaluation, so like I said, we have been moving also, right? We use LCB, like length compliant blue score. And now we looked at multiple metrics before running the task to validate which metric actually suits best at that time. So we compared Comet, Blue, Bird score, Character F score, and maybe a couple of more. So Bird score kind of was picked because it was kind of invariant to the length which we wanted. At the same time, of course, in terms of system rankings, it still stand out and compared well with the others like Comet. So this is why we kind of picked Bird score, because even if it's invariant to length, we have a variable of length compliance that we can plug in and understand the overall metric would be Bird score times length compliance. So this is again happening over time. This is why our metrics keep on changing. We might even change in a couple of months, another one. Yeah, so human evaluation for that, Roman and Marco helped us with the direct assessment evaluations for translation quality. We'll use average DAZ score there. For dubbing evaluation, we use a subsample of the blind set. We are around 60 dialogues. So there were around 15 video clips, each containing 4 consecutive dialogues. We had the outputs from multiple system, around 31 systems that we had. We annotated these system outputs for dubbing, and we provided the reference stub, and then we asked the annotators to annotate each clip. We hired 20 annotators to annotate each clip because we wanted to get some kind of significance results there. In the end, we had 31 system comparisons, 31 system comparisons, not 31 systems, including 2 baselines. So we had a weak baseline and a stronger baseline. And the idea was basically even if the annotators, they annotate on a scale of 0 to 10, there is a high variance. So to reduce that amount of variance, and we just looked at the percentage of wins, which is basically how many times a system fared better than the other. And this is basically our final metric to kind of rank the systems. We had 4 different teams participating in the task, one from AppTech, Huawei, another university in India from Gujarat, and the Prime Video team who are also working on that. So yeah, I mean, it was interesting because it was the first time we were organizing this task. We got 4 different participants. So that talks about, there is some interest. Maybe there's a lack of data, lack of community there. So we trying to build more here. And I think that we should just keep that up. Yeah, talk about it a bit more. We are still compiling the results, analyzing the results, and watch out for the overview paper. More on isometric MD. So we have the shared task and the isometric MD webpage. Again, thanks to Surafal there. Just want to plug that in that we are hiring. So if anybody sees that on YouTube, of course, look out for us, reach out to me or Marcello or anyone. Yeah, thank you. I think just on time. Okay.
Perfect. Thank you very much. Yeah. We have a relatively silent clap on YouTube, but we've got some emoji applause. All right. Awesome. Okay. Well, thank you for a great talk, first off. If anyone has any questions, yeah, please feel free to unmute and ask.
So if you want to see voiceover example, I have that too, if there are no questions.
I have a question, but I'm curious to see the Satoshi has a question as well. So I don't know,
Okay,
Liz.
yeah.
I have a question, but I'm also curious to see the example.
Okay. Let me just play that.
Okay.
Veamos. Echemos un vistazo a la caja. Tiene un lindo barnizado. Aquí se muestra más o menos cómo se ve el monopatín en acción. Ese de ahí es el perro que no tengo. Y alguien patinando por una linda ciudad. Y en la caja, veamos qué hay adentro.
Yeah, so you see that the voice is kind of laid over the original audio.
Mm-hmm.
Yeah.
Let's start with Marco, maybe.
Let's go with Satoshi. He raised the hand before me, so.
Perfect.
Satoshi.
Okay.
Okay, thank you very much. So yeah, thank you very much for it's a great talk. So I have several questions. First one is the so you the verbosity token control. There are only 3 control tokens: long, normal, short. These are enough, or maybe we need to we need to find a more finer control mechanism for this purpose.
That's a good point. Yeah, I mean, if you have other questions, you can continue, and then I can try to answer.
Okay. The second question is actually isochrony part. So speaking rate itself has a meaning, right? So the previous sentence is fast, and second sentence slow, and third sentence is fast again. But this sentence speaking rate change has some different meaning. So we have to, how to say, keep the consistency of the speaking rate.
That's true. Yeah.
So what do you think about this part? So this two questions, please.
Yeah. So for the first one, yes, I think that's a great point. I might not have a good answer for you, but I personally have thought about like why just these 3, and you can essentially even granularize this out in terms of I've seen a recent work by Google on just they add a kind of yeah, I'm not sure, it's David Villar's paper and Artem's paper where they kind of control on a granular level these constraints, not just the verbosity, but also for style, like formality. So you can even switch that using embeddings there. So it could be even a finer control. So like positional encodings, we could try to use even these.
If we make it too short, and then blue score will decrease. So
yeah, exactly. Yeah, it's a whack-a-mole situation. You try to improve
yes.
one, and you
right.
Yeah.
How about speaking rate inconsistency?
Yeah. So this is a good point. So I think if I get the question right, your point is we should try to maintain the speaking rate in the original ones. Like even in the original ones, they could be slow, fast, and slow. And we would want to essentially maintain that. Yeah, I think this is where the speaking match comes into picture, if I'm not wrong, Yogesh. So we try to see what's the speaking rate of the source prosodic phrase and the target prosodic phrase. And if it's too different, then we kind of penalize that. So we try to maintain the same speaking rate across the phrases. Yeah.
Okay, thank you. Thank you very much.
Yeah.
So now Marco, please.
Oh, thanks. Now my question is much simpler. So I go to Isochrony. So when you translate from two languages which have the same word order, like in the example you show us, it seems quite feasible. But when you go into German, for instance, because then it's not only the problem of finding the pauses, but also to match a word which is somehow similar to the one which is in the other language in terms of length and everything. Do you have any thoughts about that?
It's a problem that we are still looking at. I would say, looking at different word order languages. This is why like we have picked up on FIGs first. German, of course, doesn't give us always good results, whereas French, Italian, and Spanish, they are more in line to each other sometimes. Yeah, I would say that this is still an unexplored area, and we still need to understand. I mean, this is the same thing with simultaneous MT also, I think, where you have a lot of word reorderings, but how do you manage that?
Yeah, this is a big problem for interpreters. And the human, what to do. They start talking. With feeling the time until they get the verb at the end in German, something like that. So maybe this is the solution also for a machine.
Yeah, just like there could be like a weight case solution, or even more finer there. Yeah.
Okay, thanks.
This was actually going to be my question as well. What do you do when you have prosodic phrases of different orders and lengths? Okay, but we have another question. Synchrony, do you want to unmute and ask?
Hi, so thank you for the nice talk. So I have a question about the isometric, the MT. When you show the example between standard MT and isometric MT, it seems that the length it's better matching for isometric MT, but the word, I feel that the standard MT is still better because some word is more matching. So I was wondering whether you may need to consider not only the length, but also the pronunciation of the word, because in the end, when you dubbing, it will be better in the end.
That's a great point. I think this is why I would want to move into syllable kind of environment, where we actually look into words which are ending with maybe vowels, so we could stretch those or contract those easily. Yeah, so this is something to look into, definitely. And we haven't started exploring that, to be honest. Yeah.
Okay, thank you.
Marco, you are muted.
I'm muted, sorry. In relation to this question, I was wondering if how the problem of isometric is related to test simplification. Because at the end, when you're going to shrink or squeeze the text, you want to somehow simplify the text.
That's a great point. Yes. I haven't looked into that, to be honest. Could be something we could look into. Yeah. Yeah, it's a way of rephrasing. So like I used a lot of times rephrasing word in this talk, and I think this is where maybe text simplification could come into picture. Yeah.
Yeah, or paraphrasing, because somehow you are, if you assume you have the verbose translation, you are paraphrasing the translation, constraining it to some standard rules.
Exactly. Yeah, that could be, yeah, maybe a good paper for next time.
I want to be in acknowledgement.
Yeah.
We've got another question from Satoshi.
Yeah.
Okay. So I have one more question. So actually, I did several work on audio-visual speech translation before 10 years ago, and the task was translate the speaker's speaking face and speech at the same time from the movie. And historically, the people allow us to, how to say, change their voice, but not allowed to modify the face image. So what do you think about this? So the owner of the movie doesn't allow to modify the face.
It's yes, and this is where there could be different policies come into picture. I mean, I haven't mentioned this particular policy, but yes, there are rights, labor rights that we need to take into account when we are looking at lip sync, even when we are changing the lips of the actors. They might not allow that. Yeah, and definitely there are restrictions on that, and I think we can only change what we have rights for. Otherwise, it doesn't, work out.
Yeah. So this kind of the online video conference, so we can change, modify the faces, lip part. But for movie, the rights, copyright rights are strictly controlled. So maybe Amazon Power can do something.
Yeah, that could be it. Why not?
Yeah. Okay, thank you.
It's me again. Sorry, you didn't talk. I mean, you didn't mention too much about the lip sync problem.
Yeah, that's something that we are still thinking about. I mean, I would cover that in another talk maybe sometime. But yeah, I think lip sync or syncing the translations with the lips, it's another problem that we are facing, and we need to work on that. And it's not just that you have to generate translations. Even with TTS or even with the video, if TTS is not correct, then we have to, like, at each level, we have to look into whether we are syncing with the lips or not. It's not just translation, but at every step of the way of generation. Yeah.
So we have some work a couple of years ago, but then the big problem there to find data where you can easily identify lip sync. We look at several datasets, and even though it's mentioned that lip sync is one of the main characteristics of dubbings, we didn't find a lot of data where really there is a strong lip sync between the source and the target. Also because, this is my understanding, maybe it's wrong, is that when they dub, they have a lot of constraints. Some of them are more important than others. So some other are relaxed, and our feeling is that lip sync is one of them. But
I mean, there needs to be synchronization essentially with the phonemes and the voicemes. So we need to look into that. And create data. I think it's one of the main issues right now. create more data as much as possible. Yeah. Hopefully we should have some in like another year or two. I would say it's a lot of effort. Yeah. Great.
Do we have any last questions? Well, I guess with that, thank you very much for both a great talk and a great discussion section, and everyone for asking many questions. So that was great.
So I have an announcement. So so first of all, we would like to encourage the SIG member to register at ACL, ISCA, and ERRA, because we are supporting them and we are part of them. So it's important that we give our support also to this organization. And then the next seminar will be in June. We are contacting a couple of persons on interesting topic, like one is on speech translation again, SIMS translation, and the other one is about, sorry, it's 2 a.m. here, so I'm getting very slow, is about sign language, which is another interesting topic I think we want. So yeah, let's see what will be the next one. You will receive announcement on the mailing list. So that's all for me. Time to go to bed.
Yeah, thank you very much.
Okay, good night.
Thank you, everyone.
Good night, everyone.
Thank you, Prashant.
Thank you.
Thank you. Bye-bye.
Thank you very much. Good, great talk.